What I'm going to do is give you a very, very fast update on the helium-3 business scenario as we see it, and hope that those of you who have shown such a fantastic level of imagination in all aspects of a return to the moon will just in the back of your mind remember that there is a very, very interesting scenario involving helium-3. And it, of course, involves terrestrial energy as its primary foundation. Energy is so important to the political as well as technical and human future here on Earth that we can't ignore it. National security is clearly at stake, not only for the United States, but for many countries. And energy supply questions are now focused on fossil fuels, and particularly those in the Middle East. There are population and standard of living pressures that we have to be thinking about all the time, and of course a background of environmental uncertainty that is part of this whole energy picture. The problem, of course, is approximately 10 billion Earthlings are going to appear on Earth within the next 50 years, and if you look at the numbers, I think you can convince yourself that at least a factor of 8 increase in energy demand will occur, and how we provide that demand is an open question. The total energy use in the world has increased by a factor of 4 just since World War II. Over 10 billion barrels of oil equivalent energy is needed just in this current century. And if you just want to illustrate further political issue that we are faced with long term, and that is where energy is used, it is certainly essential for the health, economy, and safety of the developed world. For the United States, we feel, and I feel very strongly, it's essential to the preservation of our freedom, but you have to keep looking to where the lights aren't burning. That's where the primary increase in demand is going to occur, and the demand that we must satisfy. Certainly, ace in the hole is our fossil fuels. The only question is that if you depend totally on fossil fuels for a factor of 8 increase, we have an unknown impact on the terrestrial climate. Fission is clearly an ace in the hole, and some countries are grasping fission very firmly, but many countries are not. Certainly the United States is not grasping it as firmly as we should, and therefore we not only have limited influence, but we have problems of waste disposal and or conversion. The out-of-the-box solution that I'm most interested in right now, having looked at others as well, is helium-3. The School of Business at Wisconsin some years ago did a look at the business model for just the lunar portion of a helium-3 enterprise. First approximation is that launch costs for that enterprise would need to be at less than $2,000 a kilogram, and I think that if we could find a way to get launch costs at that level, we would have many, many things that we would be doing in space. I personally, as most of you know, think that that is possible, even with just an upgraded model of the Saturn V, say a Saturn VI, and long-term production contracts, but that is clearly one of the major issues. Space law is an interesting question. I personally look at it as permissive. If you look at the only operative treaty that is recognized worldwide, that's the Outer Space Treaty of '67. It is permissive, but you still need support from the United States government, I think, to make that case worldwide. And most importantly, for all of our options is access to capital markets. Near-term applications are a key. For the helium-3 energy question, we have to look, I think, at the Earth and the Moon as one environmental system. And helium-3 fuel, of course, for fusion power is present, we believe, ultimately in economically significant quantities in the lunar surface. It is in the regolith, along with other resources, that in the helium-3 question, those other resources become byproducts, because they really would be paid for pretty much on the backs of a helium-3 option. The availability is well documented, and the geology of helium-3, as well as the other solar wind resources in the lunar regolith, is well understood. What we're interested in is the fact that protons are produced rather than neutrons. Neutrons from fusion reactors are the commercial death knell of DT fusion, which is the current focus of most worldwide efforts. However, with protons, you have the ability to control those particles as well as to convert them directly to electricity. The problem is neutrons. And the worst, in spite of what sometimes people think, is the DD cycle. They are not as high energy neutrons, but there are far more of them than even with the DD cycle. But when you get into D helium-3, neutrons are very low in amount. You can drive them down to those levels by lacing the fuel with helium-3. And then, of course, with helium-3, it just goes to zero. There are no neutrons produced in that, and therefore no residual radioactivity in either your plant or anything else. Now, looking at the societal and technical concerns relative to the various nuclear options, certainly fission, there are lots of concerns, still are, proliferation, nuclear waste, radiological hazard, but the physics has been worked through and they're online and operating. So that pretty well has taken care of itself. D-helium-3, the proliferation, nuclear waste, and radiological hazard questions go away. It's just the physics is tough. And with helium-3, of course, it's very tough physics. None of these other problems exist.